Hello, my lovely darlings. We are on what I think is page 2 of the packet I gave you. I'm looking at a scanned copy from a previous year and it's not the same page. This is what it should be at the top, but we're going down to this section here. It should be on the back of the first page where it's talking about like terms. And like terms is one of the most important parts of today's lesson. If you don't know what like terms are, you're really going to struggle with this. But if you do know what like terms are, it's going to be very easy, especially if you know your integer rules. Now, if you're still struggling with the integer rules, it's going to be a little more difficult. But like terms are monomial terms, and don't stress about the word monomial. We'll talk about that more on Friday. But they're either, like terms are either identical or differ only in their coefficients, such as 3p and negative 5p. See how they both have a p, but the coefficients are different? Or 2x squared y and 8x squared y. My big thing about like terms to remember is that it has the same variable or variables to the same power. So just to give you an example here, 3x squared and negative 2x squared are like terms. But if I had, so these two are like terms. But if I had 3x to the third and 4x to the fifth, those are not like terms because one is to the third power and one is to the fifth power. Now, if you look at this second one here, you can have letters that are different, but they have to be exactly the same. So see how this x has a power of 2, this x also has to have a power of 2. And this y is to the first power, and this y is to the first power. That's what makes them like terms. The number in the front, called the coefficient, can be different. Terms can only be added or subtracted if they are like terms. If terms are not same variable to the same power, we can't add them together. We have to leave them written side by side. So let's go down a little bit on the page here, and we're going to do these two examples here. So the example says 6xy plus 2y plus 6x plus 6xy minus x. Since all of this is addition and subtraction, we don't really need those parentheses here. But they are there to show that this is one polynomial here and here's another one. Again, polynomial is a word we're going to talk about on Friday. For now, you just need to know it's an expression here. So what you want to do is you just want to add the like terms. So 6xy and 4xy are like terms, and there's a plus sign in between. So 6 plus 4 is 10, and then you just put the xy. So it's kind of like I have 6 apples over here, 4 apples over here. I put them together, that's 10 apples. What you call it does not change. The xy does not change, but the number in front changes. And I'm going to switch colors. We have a 2y here. It's got a plus sign in front of it. There are no other y terms here, so we just write plus 2y because there's nothing I can combine it with there. Then I have a plus 6x and a minus x. You have to look at those signs in front and what's in between here. So 6 plus negative 1 would be positive 5. So we put plus 5x. And then we look, we have no more like terms. And so that is our answer. We just added the coefficients on the ones that were alike and put the sign in between the others. And that's all there is to adding polynomials. So let's try another. We got 3p squared and 1p squared, because remember there's an invisible 1 in front of it if they don't put 1 there. So 3 plus 1 is 4, and then we just write the p squared. Remember, this is not where we are multiplying things, therefore we don't need to change the exponent. We did a section on exponent rules not long ago, but in that case we were multiplying them. Here we're not multiplying them, we're adding them. Next I have a minus 2p and a minus 7p. So negative 2 plus negative 7 is negative 9p. Now, if the minus confuses you and you can't tell whether it's a minus or whether it's a negative, you can always do like we did in integer rules in 7th grade, keep, change, change, where you change it to plus a negative, and keep, change, change, and that makes it easier to see these are two negatives we're adding there. And then finally, we've got a plus 3 and a plus 7. There's a plus sign in the middle here, so 3 plus 7 is 10. And that is your answer. Now, I want you to pause the video, right now and to do the you try on your own. Pause the video and see if you can do this problem on your own. Hopefully you paused the video like I asked, so we're going to go over and check your answer. So we've got 2x squared and minus 6x squared with a plus sign in between. So 2 plus, remember you could do keep, change, and make that negative 6. So 2 plus negative 6 is negative 4x squared. Then I have a positive 5x and a negative 1xy. So 5xy plus negative 1xy is 4 because 5 plus negative 1 is 4. And then I have a 4y squared and a 2y squared. So 4 plus 2 is 6y squared. Now, you don't have to have yours in the same order that I do. If you wanted to put the 6y squared in front, that would be perfectly fine. But you have to have a minus or a negative sign in front of this 4x squared and plus signs everywhere else. Now, you might notice I'm using different colors, and that's to kind of help us mark what the like terms are. Sometimes I tell students if they don't have different colors, you can mark it by doing shapes. For instance, I could put a circle kind of around the ones that are like terms, and then another one I could put a box around and a triangle around. You do whatever helps you the most. Now let's scroll down to the bottom of the page. When subtracting polynomials, you must distribute the minus sign to every term in the second parenthesis. So we're going to look at some subtraction ones now. When we look at the subtraction ones, there is a minus sign right here in the center. When we subtract, we're going to have to subtract every term in that second one. Subtraction is a little more complicated than addition because we have to remember to do that subtraction between each piece. So if I start here, 8p, there is not another p term in this entire thing. So we would just start by writing 8p. Then I have minus 5r. So we can think of that as a negative 5r, and then over here, a plus 6r. But that is a negative 5, I'm going to write it over here to the side, minus a positive 6. Because the minus sign is right here in between. So negative 5 minus 6 is actually negative 11, and then we keep the r with it because that was the type of term. Now we have one more term back here in the back we haven't done anything with. No, we have two terms in the back, excuse me. This negative 6p and this negative 3. We've got to make sure to give that minus sign to both of those. So minus negative 6, a minus a negative is actually plus a positive. And then again, a minus a negative is plus a positive. You will then see that some places rearrange the order and make the exponents go from largest to smallest, and we'll talk about that another day as well. If you have the same letters and coefficients that are supposed to be with it and it doesn't say anything about standard form, which again we'll talk about later, then I don't care what order you have it in. Now, we could have done the same problem, draw a line right here, minus 8p, parentheses 8p, with a minus sign there. And if you are better at adding, which most people are, you could start by rewriting this to begin with. So if I'm going to rewrite it, I would leave the 8p minus 5r in front. But if I want to change this to a plus sign here using integer rules, we'd have to make it a plus and then change the sign of everything in the back. So negative would make a positive 6p squared. A negative times a positive would make a minus 6r, and then a negative times a negative would make a plus 3. And then we could use our adding rules to end up with the same answer we had up here. So I'm just going to put a box around this piece here so that you can see that's what our final answer was. Now, in case you think you would like this second one better, I'm actually going to start this one over here using that method. So I'm just going to rewrite 8x squared minus 4x plus 3. And then when I get here, I'm going to distribute that minus sign. So a negative times a negative is a positive. A negative times a negative again is a positive. and a negative times a positive is a negative. So when we distribute that minus sign, we have to change the sign on everything inside that second parenthesis. And now we can combine like terms. So I have an 8x squared and a plus x squared. So 8 plus 1 is 9x squared. Then I have a negative 4x and a positive 2x, so that's negative 2x. And then I have a positive 3 and a negative 5, so that is negative 2. If you put plus signs in between them but had negatives on the next piece, that is the same thing. So you need to know for multiple choice that these two answers are exactly the same. Now, if you kind of see how adding and subtracting polynomials work, then you can go ahead to the con on the next piece. If you're still struggling a little bit, I can give you an email to another video to watch some more practice with this. But if the cons are working for you, that's great. If not, please email me and I will send you a link to another video to kind of help you get better with this. Have a great day, guys.